Okay, welcome everybody. So in this video, I want to continue working with vector spaces and functions that may or may not define an inner product on a vector space. So we're still going to work with a more concrete vector space, which is R2. So our vectors are really column vectors with two entries. But now, rather than define the inner product with the usual dot product, we're going to flip things around a little bit, and I'm going to define the inner, or this function u and v, as u1 times v2 plus u2 times v1. So we're going to kind of interchange which terms we multiply together. And so I want to determine whether this vector space with this function defines an inner product space. So that means we need to check whether this function satisfies the four required properties for it to be an inner product. So the first property is we want to check to see whether the inner product of u with v is going to give us the same thing as the inner product of v with u. So taking the inner product of u with v, we get u1 v2 plus u2 v1, and then we can change the order that we take these products and that we add things. So I'm going to take this term, write it first as v1 times u2, and then take this second, or what was this first term, and now write it second as the product v2 times u1. And this is exactly the inner product of v, first v with u. So we can see that it does not matter the order that we take these inner products. So the first property is satisfied. The second property is dealing with, well, what happens if I first add vectors u and w and then take the inner product with v? Is that the same thing as if I added the inner product of u and v with the inner product of w and v? So u plus w would have its first component would be u1 plus w1. We multiply that by v2, and then we take the second entry in the vector u plus w, which would be u2 plus w2, and we multiply that by the first entry in vector v. And now we can reorder our terms. So I can write this as u1 times v2 plus u2 times v1. So those terms are organized here, plus w1 times v2, we got that over here, plus w2 times v1, we've got that over there. So this first term is the inner product of u with v. This second term is the inner product of w with v. So this second property checks out. The third property deals with multiplication by a scalar through this function. So if I first multiply scalar c times vector u and take the inner product with v, I would get c times u1 times v2, and then the second component of u, the second entry in vector u, would be the scalar c times u2, all times the first entry in vector v, which is v1. And now I have a c being multiplied into both of those terms, so we could factor it out. And now we have exactly c times the inner product of u with v. So far, so good. We've got a check mark for property 1, 2, and 3. We've got one more property to go. So this one deals with, well, what happens when I take the inner product of u with itself? So let's consider the vector 1, 0, which is a vector in R2. So if I take the inner product of this vector u with itself, then it tells me that we're going to take u1 times u2 plus u2 times u1. And because both of these terms have u2 in them, which is 0, we get 0 plus 0 gives us 0. So here I found a vector u, which is not the 0 vector in R2, but the inner product of u with itself does give us 0. So this does not satisfy that fourth condition. So this tells me that property 4 is no good, and we need all four of them to be satisfied for all such vectors u, v, w, and scalar c. And so property 4 does not hold, so therefore that means this operation does not result in an inner product space.